Okay, so good afternoon to everyone. Then we start in the last class we have already discussed about the four operations we have discussed, and the first type using the we have discussed. So this is the fifth one, that is the machine control instruction. Now the machine control instruction is what? This machine control instruction, this is a set of instruction used to control the functions of the machine. That means to control the functions of the machine, these instructions are used. Now, what are those instructions? Like HLT, halt. This HLT means halt. Now, here you see no operands we are using. The machine control instruction, we do not use any operands. We do not use any operands in the machine control instruction. Only the instruction is specified. That's why you see no other operands are specified here. And these instructions are what? This instruction is used to control the functions of the machine. Now, what is this HLT? HLT means halt instruction. If we say NOP, NOP means no operation. If we use DI, DI means disable interrupt. If we use EI, EI means enable interrupt. If we use SIM and RIM, sequence interrupt and registers interrupt. So these are what SIM and RIM is. So like this, what we have used here, this is at the machine control instruction. This is what? This is our machine control instruction. Now that these instructions are used to control the SIM, I have said SIM is what? SIM is serial interrupt mask. Sorry, SIM is serial interrupt mask, and RIM is read interrupt mask. SIM is serial interrupt mask, RIM is read interrupt mask. So these are the machine control instruction. Now we will first, this is the based on the functionality we have seen. Now we will see based on the byte length. The second way that we can classify the instruction, that is based on the byte length. So based on the byte length is what? We have 3 bytes instruction: single byte instruction, 2 byte instruction, and 3 byte instruction. These 3 types are present for byte length, because we have a single byte instruction present, maybe 2 byte instruction, or maybe 3 byte instruction. These are present. So the first one, we will discuss the single byte instruction. Now single byte instruction, from the name you are understanding that single means only one instruction should be there. That means which requires a single byte in machine code. That's why its name is single byte instruction. That means only a single byte will be required here. And that is both the opcode and the operand are included in the same byte. That means the operand and the opcode will be presented in the same byte. Now, what is, already we have discussed what is opcode and operand. Opcode means what? Opcode is the part of instruction which specifies which type of operations we should perform. That is the opcode. That means if we say, as an example, let's say we write ADD B, ADD B. That means this ADD is what? This ADD is our opcode. This is the opcode. That means which operations should be performed. That is specified by the opcode. And what is the operand? Operand is over which the opcode will perform the operation. Operand is the data. So here, what will be the operand? This B will be the operand. So basically, what it is specifying, that this both opcode and operand are included in the same byte. for the single byte instruction. This is what, this is the single byte instruction. This is a single byte instruction because here you see opcode and operand are specified. Opcode and operand are included in the same byte. These are included in the same byte. So this is why it is called the our single byte instruction. Then this is what HLT. This is also, we can say, a single instruction. Let's say we have etc. like this, only where opcode and operands are included in the same byte, then we call that as the single byte instruction. Now, how you will know that this is the shortcut tricks to know that which operations is the our single byte instruction, which operation? Then the shortcut tricks is what? If the instruction, this is the shortcut trick to remember, that if there is no instruction, no numerical value given, then that will be the single byte instruction. This is the shortcut trick to remember. This is the shortcut trick to remember. That means if in the instruction no numerical value is present, then that means that instruction is the single byte instruction. Here you see add ADDB. In this, no numerical value is present. So that means this is the short, we can say that this is the our single byte instruction, but this is the shortcut tricks. But main thing is what? If the opcode and operand are included in the same byte, then we call that as the single byte instruction. Then after that single byte instruction, what this is? 2 byte instruction. Now 2 byte instruction means what? This instructions will require 2 byte. This instructions will require what? This instruction will require 2 bytes in the machine code. Now example is what? Now let's say example, that is we have written MVI A, comma 08 H. This is what? This is a 2 byte instruction. Now what this means? This is 08H. This is a, and here we in this command we are mentioning MVI. That means MVI means what? Move immediate. That's why it is I present. So move immediate. That means this 08H is what? This 08H is a data. This data will be moved to the A. A means what? Here specifically mentioned accumulator, or we can say A is a register. So in this A register, this 08H data will be moved. That's why here the data is directly moving. This data is directly moving to a register content. So that's why it is mentioned immediate. If there I have mentioned, let's say another register or the memory location, in that case, I will not give the I, because I means what? Immediate transfer of data from that data to the register or the memory. So immediate transfer, if immediate transfer is done, then I will mention the I. But if let's say from another register the data is moved to this register, in that case I will only write MOV, move A comma B, like this, if that is the 2 register case. But let's say the discussion is what? This discussion is for the 2 bytes instruction. That means this instructions will require 2 byte. Now to remember that, what is the clue? The clue is that it will contain one 8-bit numerical value. One 8-bit numerical value. So this is what? This is for the, if we say, this will be for the 2 byte instruction. And for the 3 byte instruction, the 3 bytes will be in the machine code. Now that means what? This is the 3 byte instruction, LDA. It is written LDA. LDA 9000 H. This 9000 H is what? This 9000H is a memory location. This is a memory location. That means in this 9000H, the data that is present will be loaded to the accumulator, will be loaded into the accumulator. That's why it is mentioned LDA. LD means load. Load to the accumulator. The data that is present in this 9000H memory location will be moved to the accumulator. And the clue to remember is what? These instructions will contain a 16-bit numerical value. So first one is what? For the first instruction, if there is a single byte instruction, then there will be no numerical value present. If it is 2-byte instruction, then that means what? 8-bit. The 8-bit numerical value should be present. And for the 3-byte instruction, it will be what? For 3-byte instruction, there will be 16-bit. There will be 16-bit numerical value should be present. Now, how we are calculating the 16-bit? This LDA. This LDA is what? This is the opcode. This LDA is the opcode. So that means this LDA is one first byte. This LDA is first byte. And this 9000H will divide like this. This 2, this 2. So that means what? This total 2 and this 2. So this will be what? This 00. This is the second byte. And this 90 is what? This is the third. So like this, we divide this as a 3-byte instruction like this. That means LDA will be the opcode. So this opcode is the first byte. This 9000H is what? In this 9000H, this 00 will be what? This 00, we will divide this as the second byte. And this is what? This is the third byte. So this total instruction is 3-byte instruction. But for easy shortcut tricks, only remember, this is what? This is a 16-bit address, because this is a hexadecimal. So that means this is a 16-bit address. So for easy way to remember that this is a 16-bit numerical value should be present in our instruction. That instruction we call as the 3-byte instruction. Okay, clear? It is clear to everyone?
Yes, sir.
Yes, sir.
Okay. So now we will move on to the third type. The third type is based on the addressing mode. The addressing mode which we have seen already, that addressing mode. Now, how many addressing mode are present? We will know that. Now, the process of specifying data to be operated on by the instruction is called the addressing. That means it is the specifying of the data. The specifying of the data to be operated on by the instruction is called the addressing. And the various format for specifying the operands, the various formats we use, that various formats for specifying the operands are called the addressing mode. Now we have several types of addressing mode. We will discuss that one by one. The first addressing mode is immediate addressing mode. Now, what is this immediate addressing mode is? Now, immediate addressing transfer the operand given in the instruction to the register or to the memory specified in the instruction. And the operand is also the part of the instruction. Now here, this is what the instruction format will look like this. In this instruction format, this will be divided into two parts. One is the opcode and another one is the operand. Now, let's say this is the instruction MVI A,08H. So immediate means what? I should be present there. If Immediate transfer means what? The data should be transferred to that particular data should be transferred to a register, or that particular data should be transferred to the our any memory location. Or immediate addition or immediate subtraction, all of this immediate operation will be placed in the immediate addressing mode. So that is what it is written, immediate addressing, transfer the operand given in the instruction. That means transfer the operand. This is what the operand mentioned in the instruction. This operand to the register or the memory specified in the instruction. And that operand should be the part of the instruction. So here, if we see this example, you see this 08H is what? This 08H is operand. This operand is what? This operand is specified in the instruction. Because this 08H is what? In the instruction, it is mentioned. Now this 08H, this data, we are moving to A. Now A is what? A is a register. A is a register or accumulator. Accumulator or A. Both of this is what? A register. So that means this data is transferred to the register A or to the accumulator. And this we called as the immediate. This we called as the immediate. You see, we have write I. So MVI, move immediate. So that means the data should be transferred to the register. So this is what? This is the definition says. Immediate addressing mode definition says that in the instruction, the operand or the data should be mentioned. And that operand should be transferred to the memory or the register, and that total operand should be specified in the instruction, both of which this thing is suggesting by the instruction. So that's why this we can call as the addressing mode, immediate addressing mode instruction. This instruction we can call as the our immediate addressing mode instruction. Then next instruction, ADI 55H. This 55 is what? This 55H is the operand or the data, and this data here nothing is mentioned. So that means what? We are doing the operation with whom? We are doing the operation with the content of the accumulator, because if nothing is mentioned, that means that is the accumulator. So that the content of the accumulator, with the content of the accumulator, this 55H should be added. So this is what? That's why this is I mentioned. So any immediate operation that should be is the immediate addressing mode. This is another clue you should be in mind, that any immediate operation, that immediate operation should be immediate addressing mode. That immediate operation should be the, or the immediate instruction like this event, then it should be placed on the immediate addressing. Now the next is what? The memory direct addressing mode. The memory direct addressing mode. So the name, from the name we can say that here what will happen? This addressing mode moves a data or a byte between a memory location and a register. The memory location address will be given in the instruction. That is the thing. That means from the name we are saying memory direct addressing mode. That means the memory is related. The instruction which is related to the memory. That means memory address should be specified in the instruction. That specified instruction in which the memory is specified, memory location. We can generalize say that the memory location is specified. That instruction should be the memory direct addressing mode. That means the instruction format will be what? We all know that the instruction format is what? First will be the opcode, second will be the operand. So in this type of memory direct addressing mode instruction, the first one will be the opcode, that is same. The second one will be the operand, but like this, here the operand is directly mentioned. That means the operand or the data is directly mentioned in the immediate case. But in the memory direct addressing case, in this operand section, what will be mentioned? The memory location will be mentioned. That's why it is called the memory direct addressing mode. That means there will be the opcode, and in the case of the operand, what will be present? In the case of the operand, it will be memory address. Sorry. So here in case of operand, there will be the mention by the memory address. And if we go to that particular memory address, inside of that particular memory address, the operand is loaded. So if we see its example, or if we see its diagram, you will able to know that. That what you see, the instruction is what? The instruction is mentioned, the opcode is there. But in case of the operand, in the place of operand, what we are mentioning? The memory address. And that inside that particular memory address, the operand is stored. So in the case of immediate addressing mode, inside the instruction, we are directly mentioning the operand. We are directly mentioning the operand. But in the memory direct addressing mode, what will be there? The opcode should be present and the memory address should be present. Then where will be the operand? The operand will be present inside that particular memory address which is given. So here, this is the instruction, you see, LDA 9000H. So that means load accumulator. So this is what? This is the opcode section. LDA is the opcode section. And this is what? This is the memory address. So that's how the instruction is divided. And this is the memory address. So inside this memory address, the data is stored. The data is stored inside this memory address. And that data should be transferred to the accumulator. So LDA means what? Load accumulator. And if this is mentioned STA 9500H, so STA is what? It will be the opcode. And this is what? This is the memory address. And inside this 9500H memory location, the data is stored. That data should be transferred or stored into the accumulator. So this is what the instruction format look like. That means in the instruction format for the shortcut tricks, remember, if in any instruction format the memory location is given, that means that instruction is the memory direct addressing mode. That instruction is the memory direct addressing mode. Okay, clear till now? Anyone has any question? It is clear to everyone?
Yes, sir.
Okay.
Yes, sir.
This is the case of the memory direct addressing. Then the register direct addressing mode. So what is the register direct addressing mode? From the name, we can say that this addressing mode transfer a copy of a byte or a word, transfer the copy of byte or a word from the source register to the destination register. That's why it is called the register direct addressing mode. That means here the register will be there, the registered thing will be there. That's why we are calling it as the register direct addressing mode. And here what will happen? In this addressing mode, transfer a copy or a byte or a word from the source register to the destination register. And the register which contains the operand will be specified in the instruction, will be specified in the instruction, and that instructions will be executed very fast, but it is very limited register place or space, because in our system we have small number of registers. Mainly in our systems we have small number of register, because register cost is much. So that's why in our system we have small number of register. So that's why, and register space is also low. So basically register direct addressing mode we use sometimes, not always we use the register direct addressing mode, we use some of times. But here what will happen, in here the instructions will be there, the instructions like this, the instruction is, and this instructions will be like this two parts. The first part will be the opcode, and in place of the memory address there will be the register, there will be the register's address, not register address, the register will be there, the specified named register will be there, and in that, inside that register the operand will be present. So if we see the diagram, that is what, that means the instruction is what, let's see, this instruction, it is divided two parts. In this case, for the register direct addressing mode, the first part will be the opcode, and the second part will be what, that particular register which is using, that particular register will be there, and inside that register the operand is specified. So let's say, that is, it can also happen that in the only a register name is mentioned, or the source or destination register, this can also be mentioned. That's why in the first case, you see, in the first case mov, move a comma b, so a is what, a destination register, and b is what, b is the source register, b is our source register. So that means from the b, from the content of b, the content of b, it is moved to the content of a. That means from source to destination, from source register's content, it is moved to the destination register content. So this can also happen. The second one is what, ADDC. That means what, add C. C is a register mention. So that means what is happening there? The content that is present on the register C, we are adding with the content of the accumulator, and we are storing that in the final product into the accumulator again. So this is what, this is a function, this is the instruction ADDC. ADDC means what? First, the content that is present on the register C is added with the content that is currently in accumulator, the content that is present currently in the accumulator. With that content, it is adding, and the final product which we are getting, that final product is storing into the accumulator. Same as that for subtraction also, there is what, the opcode is mentioned and the register name is mentioned. This will be the instruction format look like. So that is mentioned here, sub D. So that means this is the opcode mentioned, this is the register, the named register is mentioned. That means what is happening, the content with the content of the accumulator, the content that is present in the accumulator minus the content that is present on the register D, and the product of the result which we are getting, that is storing into the, again, in the accumulator. This is what, this is the register direct addressing mode. That means register is associated here with this instructions. You see, the register is associated. So register is associated, that means it will be the register direct addressing mode. And the last, fourth one, not the last one, the fourth one is the indirect addressing mode. So what is the indirect addressing mode? Now, indirect addressing mode is what? This mode sorry, this mode transfers a byte or a word between a register and a memory location. That means the transfer of a byte or word between a register and a memory location, we call that as the indirect addressing mode. We call them as the indirect addressing mode. And the address of the memory location is stored in the register or the register pair. It will be stored into the register or register pair. And that register pair will be specified in the instruction. So here the mode of transfer, the transfer is what? Between a register and a memory location. The transfer between the register and the memory location. And the address of the memory location, the address of the memory location will be stored into the register or in the register pair. And that register pair is specified in the instruction. That means this is what the instruction format will look like this. The instruction is what? This instruction format will be divided into two parts. This two parts is what? This two parts will contain, first part will contain the opcode. The second part will contain the address of the register. The second part will contain the address of the register. Now inside this address, if we go to inside of this address, then we will find the address of the operand. Now address of the operand means what? The memory location. So the memory location is stored in this particular address of register. So in that particular register address, the memory location is stored. And after going inside that memory location, we will find the operand. So that means, let's say this is the memory location. This is our memory present. And inside this memory, in the 9000H location, this operand is stored. This in this 9000H location, this is the memory location. In this memory location, the operand is stored. And that means what? This 9000H will be stored into the register. And let's say in this 9000 is stored in the register, and there is also another address is given, and that is for the register address. That register address is mentioned in the instruction. That register address is mentioned in the instruction. So this is the indirect addressing mode. So that means we cannot find the direct addressing here. So that's why it is called indirect addressing. So that means, let's say this is the instruction. Any instruction which contains memory is the indirect addressing mode. So let's say this is what? Add m. We have a command like add m. So add m means what? This m is associated. M means what? M means memory associated. So if m is mentioned, like this capital M is mentioned, that means here the memory is involved. So if we divide this, or if we say that, then what will be the operation? The accumulator, the content of the accumulator will be added with the content of the memory, and it will be stored into the accumulator again. Now, which will hold this memory? Which will hold this memory pointer? A register pair. This HL is what? This is a register pair we have. Now, let's say this HL register pair, this is what? This is stored in the 9000H location. And inside of this 9000H location, we have the 55H. This data is present. So that is what? That the memory, inside this memory, the operand is there. The memory, the operand is present. And let's say this is the 9000H location. So this 9000H location will be stored by the register. And that means here in this, for this, there will be another location present, and that location should be present in the instruction. So for this purpose, it should be remembered that if any instruction contain capital M, if any instruction contain, then we call it as the memory indirect addressing mode. We call them as the memory indirect addressing mode, because here you see we are directly not finding In our register case, we have seen the register is mentioned. In the memory direct case, we have seen the memory location is mentioned, and that memory location we find the operand. But here what we are finding in this address of register, if we go to this address, then we will find the address of the operand. That means the particular memory location will find. Then we have to go inside that particular memory location. Then we can only able to find the our particular operand. But in that case, for register and memory location, we are directly going to that address and finding the operand. So this is the difference. This is the difference of the indirect addressing mode. And the last one is what? The last one we have present, that is implicit or implied addressing mode. Implied addressing mode. And this is what? In this instruction, itself specifies the data to be operated on. So it itself specifies that the data which be operated on itself specified. That means, let's say HLT, only HLT is given. Halt, only HLT is given. Here no operands are there. No operand should be there. Only the opcode. You see, in this instruction itself specifies the data to be operated on, or NOP, no operation. Sorry. So this is what? No operation. EI, enable interrupt. So these are all our implicit addressing mode. No operands are specified. That means this is what? This is the data in itself. In itself specifies the data to be operated on. So this we call as the implicit addressing mode. So this is all about our addressing mode. Okay. Clear to everyone?
Yes, sir. Yes, sir.
Okay.